Hi everyone, welcome to this video on lesson 11 of the atomic structure and periodic table scheme. This one's on Mendeleev's periodic table. This is a wonderful lesson because Mendeleev's thinking was just extraordinary, and it's lovely to have the opportunity to share that with students. But it is quite a challenging lesson as well, and I think it's hard for students to really grasp just how profound Mendeleev's insight was. So again, I'm not going under the visualizer here because I think this maybe isn't the best lesson for the visualizer. Actually, I think it's fine to show some videos and maybe talk through some PowerPoint slides. And I suppose what you want to illustrate to students is that there are two main differences between Newland's periodic table and Mendeleev's periodic table. So we saw in the previous lesson, Newland's had this law of octaves. He said every eighth element should react in the same way. But what we did is show students counterexamples to say, well, actually, that's not quite the case. There are some examples where that law doesn't really hold. So Mendeleev, he had a bit more information at his disposal, I suppose. And what I like to do in this lesson is start by just comparing Newland's periodic table to Mendeleev's periodic table. He's kind of made a second attempt. And what students should notice firstly is that actually they're quite similar. They're not radically different at first glance. One obvious difference that all students will pick up on is the fact that Mendeleev left gaps. The other thing that you can talk about is that he didn't organize every single element in terms of atomic weight. He kind of mixed them up a bit. And this is because he felt that getting the chemical properties, kind of grouping by the chemical properties, was more important, and that maybe there was more to be discovered around atomic weights and so on. But the point about gaps is the one that you really want them to take away. And again, this is, I think, what makes it such a profound insight. It's that he thought, well, okay, we've discovered quite a lot of elements already, but if there's a gap here, and it feels like actually these other elements would fit better in the one afterwards. So yeah, the example in the video is about Eka aluminium, and the fact that there wasn't anything to go there. He wasn't going to try and force titanium or something like that into that space. Actually, it would be better to just leave a gap and wait for those elements to be discovered. So those are the two things to highlight to students. And then, yeah, I think it's a good idea to just show students that video. It's really interesting. Quiz them a bit with the whiteboard questions and then get them answering some questions. And really, that's all that they need. There's lots and lots of more profound questions and topics that you can raise with students if you're interested. This idea that the power of a scientific theory is well, it's in its ability to generate new questions, and this is what Mendeleev's theory, or what made Mendeleev's theory so amazing, was that it suggested that we should start going and looking for these new elements, and he even predicted, and this is, I suppose, the second part of a really powerful theory, it predicted the kind of things that they should be able to find by experiment. And again, if you look at some of Einstein's work as well, he's kind of famous for this, that his theories of relativity generated all of these ideas that he said, well, go and look for these, one day you'll find them. And lo and behold, scientists did, even though in some cases it took quite a while. So there's lots of stuff you can discuss there. If you're not mega confident around talking about Einstein and you know, waxing lyrical about the beauty of Mendeleev's theory, that's absolutely fine. The main thing that they need to take away is that Mendeleev left the gaps for elements that haven't been discovered, and that sets this it sets the scene really nicely for the next lesson, which is about the modern periodic table.